The question is, why can't humans walk on water? Imagine, if you could walk on water, 71% of the Earth would be your playground. But in reality, with every step you take, you sink. Why? The answer lies in an inexorable truth of physics. The curtain of water under your feet cannot support your weight. But why is this curtain so weak? And how strong would it be if you could walk on water? In this video, we will look at it through the eyes of mathematics and science. Why you can't walk on water. Step 1. What is the surface tension of water? Water molecules hold each other very tightly. This molecular force causes the upper layer of water to behave like a stretched elastic curtain. This property is called surface tension. In scientific terms, the surface tension of pure water at a temperature of 20 degrees Celsius is gamma equals 0.07 newtons per meter. That is, each meter of the length of the water curtain can only hold 0.07 newtons of force. Step 2. How much weight can surface tension carry? The force exerted by surface tension depends on the area of contact between the water and the object. The formula is AF equals gamma times L, where F equals force caused by surface tension in newtons, gamma equals surface tension of water, 0.07 newtons per meter. L equals area of contact between water and object in meters. Suppose you weigh 65 kilograms. The acceleration due to gravity on Earth is E equals 9.8 meters per second squared. So your weight is F equals m times G equals 65 times 9.8 equals 637 newtons. Now, how much area is needed to carry this 637 newton force through surface tension? L equals F over gamma equals 637 over 0.07 is approximately 9,100 meters. That is, the area of contact between your feet and the water must be about 9.1 kilometers. A study has shown that for a 65-kilogram person to walk on water, the area of the feet must be about 1.5 square kilometers. That is much larger than a football field. Step 3. Density and buoyancy. Why you sink? Besides surface tension, there's another factor, density. The density of water is 1,000 kilograms per cubic meter, and the average human density is about 985 kilograms per cubic meter. Humans are slightly less dense than water, so if you're floating on air, the buoyancy of water can keep you afloat. But when you walk, your feet push you underwater. According to Archimedes' principle, buoyancy depends on how much water you displace. When you walk, your feet displace a little water, so the buoyancy isn't enough to support your entire weight, and surface tension is much weaker than that. Step 4. What happens when you run? Example of the basilisk lizard. What if you keep running? Science says that running on water is possible, but it requires a speed of about 30 meters per second. The world's fastest man, Usain Bolt, has a speed of only 10.4 meters per second. In addition, running at this speed requires 15 times more energy than a human being. The basilisk lizard can run on water, but it weighs only a few grams and it uses its tail and legs to generate additional force. This is not possible for humans. Step 5. Hoax and reality. YouTube shows many videos of people walking on water. These are hoaxes. Glass bridges or floating platforms are used underwater. No special shoes can solve this problem. Yes, if a motorboat pulls you with a rope, you can ski on water, but that is a different matter. It is not walking, finally. So you cannot walk on water because 1. Surface tension is very weak, only 0.07 newtons per meter. 2. It would require a radius of about 9 kilometers to carry your weight, which is impossible. 3. Buoyancy cannot completely support your weight. 4. Running requires a speed of 30 meters per second, which is beyond human ability. Science says that the water curtain is so weak that you cannot stand on it. But this same curtain is strong enough for insects. This game of the molecular world limits us. So the next time you stand next to a lake, remember, you can't. Because math and physics are not on your side. If you like the video, like and subscribe to stay with us. thank you.